In Chapter 4, Goal 14, we're going to cover how to graph sine and cosine when there's something called a phase shift. A phase shift is basically a horizontal shift. We're going to look at how to sketch a horizontal shift several different ways, and then I'll discuss with you what I think is the most efficient way to sketch a horizontal shift. So let's take a look at example A. First, as usual, predict how the graph of y equals sine of x plus pi over 2 will compare to y equals sine of x. As you're thinking about the prediction, I'd like you to go ahead and sketch y equals sine of x between 0 and 2 pi. So pause the screencast, draw that sketch, and then as you're doing that, think about your prediction. Okay, so I have sketched the parent function y equals the sine of x. And let's take a look at y equals sine of x plus pi over 2. First, I know that this is a horizontal shift because the addition of pi over 2 is inside the parentheses. And we know with any horizontal shift, we would always shift the opposite direction of the sign in parentheses. So I know that my horizontal shift is going to shift left pi over 2 radians. I also notice that in this function, a is 1, so my maximum point is 1, my minimum point is -1. I also notice that b, the coefficient of x, is 1, so my period is also 2 pi radians. So this function is not going to stretch or shrink vertically, nor is it going to stretch or shrink horizontally. Simply every one of my 5 key points is just going to shift left pi over 2 radians. So if I do this using transformations alone, I'll take 2 pi and shift it left pi over 2 radians to 3 pi over 2. I'll take my point at 3 pi over 2 and shift it left to pi. I'll take my point at pi and shift it left to pi over 2. I'll take my point at pi over 2 and shift it left to 0. And finally, I'll take my point at 0 and shift it left to negative pi over 2. And now we've shifted this left pi over 2 radians. So we can say that our phase shift is negative pi over 2 radians. Now for this function, the period remained the same and the phase shift was pretty basic and easy. But that will not always be the case. So with this exact same example, I want to show you an alternate way to shift this function according to its phase shift. And I'm going to do that based on the domain of the parent function. We know that the domain of sine and cosine is all reals. However, when I'm just discussing the domain of the parent function, I'm thinking of the fact that all my values for theta are between 0 and 2 pi. So when I'm finding my new starting point and new ending point, I want to take the value inside the parentheses and place it between the endpoints of the parent function. So I will place x plus pi over 2 between 0 and 2 pi. Remember, I'm showing you an alternate way to graph functions that have a phase shift. And I'm showing you an alternate method because, as you see in example B, we're about to get quite a bit more complex with 1, 2, 3 transformations in one function. So I'm showing you an alternate method here. Okay, so to figure out my new endpoints, where the function will begin and end, I'll now solve for x. And so to do that, we will subtract pi over 2 0 minus pi over 2 is negative pi over 2, is less than or equal to x, is less than or equal to 2 minus 1/2 is 3/2, or 3 pi over 2. So what this has given me are the endpoints for my transformed function. So if you did not already have the blue graph on this coordinate plane, I would want you to plot negative pi over 2 and 3 pi over 2, and that would give you the endpoints. And then we would take this interval and divide this into 4 equal parts. So we have our starting and ending point and our halfway point. Just as a review, even though this is already labeled, I just want to remind you to find midpoint, we add our endpoints and then multiply that by 1/2. So negative 1/2 plus 3 pi over 2 is 2 pi over 2 times 1/2 would give us pi over 2, and there's my midpoint. Halfway between negative pi over 2 and positive pi over 2 is 0, and halfway between pi over 2 and 3 pi over 2 is pi. So you should have 1, 2, 3, 4, 5, the x-coordinates of your 5 major points labeled, and then follow your pattern. Sign begins at the x-axis, maximum x-axis, minimum x-axis. So this is an alternate way to use our transformations and find the new endpoints for the function. And if using this method to figure out your phase shift, you ask yourself, how far did we shift away from 0? Well, I shifted pi over 2 radians to the left, or negative pi over 2 radians. Let's try this again in example B. I'd like you to begin in example B by analyzing this equation and determining the amplitude and the period. We'll work on the phase shift together in a moment. Pause the screencast and determine the amplitude and the period, please. Remember that amplitude comes from A, period is 2 pi over B, so our amplitude is 3, and our period is 2 pi radians divided by 3. So that means this function is going to repeat every 2 pi over 3 radians. Okay, well, this phase shift is a little more difficult to calculate here mentally, because not only are we shrinking our period, but the period is shrinking and then we're shifting it pi over 2 radians to the right. So I want us to take the value in parentheses and place it between the endpoints of the parent function. So if we take 3x minus pi over 2 and place it between the endpoints of the parent function, solving for x will not only shift right and left, but it's also going to shrink or stretch our period for us. So let's now solve for x. So I will do that by adding pi over 2. And just to mention, if you don't like working with fractions, you could sweep the fractions from the beginning. And what I mean by that is take your least common denominator and multiply every term in this inequality by that least common denominator. And now you've gotten rid of the fractions. So if you don't like fractions, that's a great thing to do. So I'll add pi in the middle. I'll add pi to 0. And I'll add pi to 4 pi. And then lastly, I will divide by 6. So what's happened here is we have shifted our function from 0 to pi over 6. So that is our phase shift. And we've also come up with our endpoints simultaneously. Let's sketch this. Since pi over 6 is my starting point, then the first value I will put on the x-axis is pi over 6 radians. And then I need to go out some distance for 5 pi over 6. So here's kind of how I think through this. Let me change colors just so you can see a little bit of a difference. Okay, I've said that this distance is pi over 6, so I'm going to just estimate the equal distances, and remember I'm trying to get to 5 pi over 6. So this dot represents 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This just helps me to stay a little bit to scale, even though it's not completely to scale, just by plotting that out. And remember, you should divide your period length into 5 equal parts. So we have our halfway mark. So let's figure out what's halfway between pi over 6 and 5 pi over 6. Remember midpoint again. We can add these numbers and take half of that. So 1/6 plus 5/6 is 6/6, and that reduces, or 6 over 6 reduces to 1. Half of that is 1/2. So the midway is pi over 2. An alternate way you could find that point is to look at your the red dots and count by pi over 6's. 1 pi over 6, 2 pi over 6, 3 pi over 6, and 3 pi over 6 reduces to pi over 2. And then our quarter marks would be 2 pi over 6 or pi over 3, and 4 pi over 6 or 2 pi over 3. Okay, remember, we have a phase shift. We're shifting from 0 to positive pi over 6. So when I graph sine, my first point will be at positive pi over 6, 0. My x-intercept will be at pi over 2, 0. And my final point will be at 5 pi over 6, 0. At this time, I'm going to plot or label my max and min values on the y-axis. Remember, I do not need you to write the words max or min or draw lines or point to the max or min. Just put them on the y-axis. And then from here, we will follow our pattern for sine. X-axis, maximum, x-axis, minimum, x-axis. Notice that the instructions ask us to sketch 2 periods. And when I tell you to sketch 2 periods, you can go, let's draw the second one off to the right or off to the left, and I prefer off to the right. So anytime you sketch a second period, the only values I require on the x-axis are the endpoints. So I note that this will start at 5 pi over 6 and then follow the pattern. But I would require you to tell me this value right here. So how do we get that? Well, this distance that I just graphed should have a period equivalent to 2 pi over 3 radians, which we already calculated. So to find that value, I'll just take 5 pi over 6 and add the period length to it. So that's 9 pi over 6, which will reduce to 3 pi over 2. Or you could keep adding 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6 till you get to it.